We've discussed how to identify a quadratic function. We've seen it on a graph, in a table of values, and in three forms of quadratic equations. Now let's talk about how to describe the transformations. Transformations are given or are seen in vertex form of an equation of a parabola. They refer to a change made from the standard parabola. Now the standard parabola is y equals x squared. When we talk about transformations, we talk about the changes from the standard parabola to the parabola we're considering in that question. So for example, if I gave you the equation y equals negative 2 bracket x plus 4 squared minus 3, this is an equation in vertex form. This parabola has a vertex of negative 4, negative 3. Remember to change the sign from the brackets. It opens down because of the negative a value, and it's very thin because of the a value of 2. Now, if we were going to describe these transformations, we would have to use mathematical language. So first of all, we'd look at the negative sign. This tells us the parabola opens down. Opening down in mathematical language would be called reflection in the x-axis. So we would say this parabola is reflected in the x-axis. We would then look at the 2 and say, okay, this 2 means that the step pattern, instead of going 1, 3, 5, it would be doubled. It would be twice as high. So we go over 1, up by 2, over 1, up by 6, over 1, up by 10. This 2 here means the parabola is stretched. So in mathematical language, we say that it's stretched vertically, because it's stretched up and down, stretched vertically. And how many times is it going to be taller? Well, it's stretched vertically by a factor of 2. A factor means you're multiplying, right? If we talk about factors of 6, they're numbers that multiply to give you 6. So we talk about stretched vertically by a factor of 2 means it's stretched 2 times taller than the standard parabola. The next transformations we're going to describe are to do with the vertex. So the vertex is not anymore at 0, 0. Now it's moved over to the left 4 units, and it's also moved down 3 units. When we look at the standard parabola, its vertex is at 0, 0. So the equation given to us here in vertex form tells us that we're going to translate the vertex. We're going to move that vertex both left and down. Remember to look at the sign in the brackets, and that it's the opposite of what you would think. This means the vertex is at negative 4. So if we see a positive 4 in the brackets, we're going to say that this parabola is going to be translated to the left. So we'll say translated, which means moved. Translated 4 units to the left. And this 3 is taken just as it is. We can say and 3 units down. We only need to change the sign when it's in the brackets. So if you were given this equation on an exam or on a summative and you were asked to describe the transformations, you would say this parabola is reflected in the x-axis, stretched vertically by a factor of 2, translated 4 units to the left, and translated 3 units down. Let's give another example. And let's look at a compression instead of a vertical stretch, just to see the difference. So let's look at the example y equals 2/3 x squared plus 5. So this again is an equation in vertex form. It looks a little bit different because there are no brackets. That just means that we don't have a horizontal translation, so it's not going to move left or right. It's just going to move up or down. So this here is a fractional a value. When a is a fraction, we're going to say that it's compressed instead of stretched vertically. So this is going to be compressed vertically by a factor of 2/3. Remember, when you're talking about a vertical compression or a vertical stretch, you're not going to say units, you're going to say by a factor of when you're describing the compression or the stretch. So compressed vertically by a factor of 2/3. And the plus 5 at the end would be translated 5 units up. So that's how you describe a quadratic transformation. You're going to talk about whether it's reflected in the x-axis, whether it's stretched or compressed vertically by a certain factor, and whether it's translated to the left, to the right, up, or down. If a transformation is not visible in vertex form, you're not going to state it. So you don't need to say that a parabola opens up, or if the equation is y equals x squared minus 4, you don't need to say that it's stretched by a factor of 1, because a factor of 1 isn't actually stretching it. That's the same as a standard parabola. When you're discussing transformations, you only have to say what has changed from the standard equation y equals x squared. In this case, it would be a translation. It would be translated down 4 units. Next, we're going to go over the topic of how to create a quadratic equation. And pay extra close attention to this because it's one of the topics that was not as well done on previous quizzes and on unit tests for Chapter 4. So we're going to call this Creating Quadratic Equations. Creating Quadratic Equations. And we're going to discuss how to do that and what the process should be for figuring out which equation you should use. So if you're going to create a quadratic equation, you have two choices of forms of an equation that you can use. We can create a quadratic equation in factored form, and we can create one in vertex form. Now we're going to write down factored form first because that's the one you're going to try to use always. So factored form. We're going to try to use this one, and we're going to use it if we're given the roots. So remember, factored form is the form where you have the roots in the actual equation. So r and s are the x-intercepts or the roots of the parabola. So you're going to use factored form always as a first kind of go-to equation if you're given the roots of the parabola. Now, if you're not given roots at all, then you're going to choose to use vertex form. So vertex form if roots are not given, but vertex is given. It's not enough to say, okay, if you have the vertex, choose vertex form, because sometimes we might give you vertex and you're still going to be able to use factored form. Always use factored form unless you don't have the roots. That's the rule. So if you're given information, for example, the roots and the vertex of the parabola, and you're supposed to create an equation, you have to start with the general form of that equation. So if you have the roots, you start with y equals a bracket x minus r, x minus s. And if you don't have the roots, you're going to start with the general form of vertex form of the equation, which is y equals a bracket x minus h squared plus k. So you're always going to start with the general form of that equation if you're going to create an equation in factored form, and you're going to choose the one that matches what you're given. So let's look at an example right now. I'm going to move this up a little bit here. Let's say that you're asked to create a quadratic equation for a parabola with roots of -1 and 3 and vertex of 2, 5. Let's say that's the information given to us in the question, and we're asked to create a quadratic equation. So the first step is, do I have the roots? And here the answer is yes, I do. So if I have the roots, I'm going to choose to use factored form. So I'm going to write down the general factored form of the equation of a parabola. So x minus r, x minus s. That's the general factored form. And that's the one I'm going to use to create this equation. Now, if the roots are -1 and +3, those are the numbers that go in the brackets for r and s, but I have to remember when they go in the brackets, we have to change their signs. So my equation is going to be y equals a bracket x. If it's -1 over here, it becomes +1 in the brackets. And if it's +3 over here, it becomes -3 in the brackets. So we plug our roots in for r and s in factored form of the parabola. The next step is whatever else we're given, whether it's a point on the parabola or whether it's the vertex, that is the x and the y in our equation. Okay, the roots come first because that's what's special about factored form. We put the roots in. And then we say, okay, the other information given, whether it's vertex or a different point, that's going to be used for our x and our y. So we're going to put 2 where the x is in this equation, and we're going to put 5 where the y is in this equation. So we're going to substitute in our values next. Instead of y, we're going to write 5. Instead of x, we're going to write 2. Now we don't know what the a value is, so we're going to keep it as a. That's the one letter that's going to be in our equation. So 2 plus 1, the plus 1 was our root, it's already there, and the 2 goes in again for x minus 3. Now the next step is just to use BEDMAS to simplify. So when you're looking at this equation, BEDMAS tells us to figure out the brackets first. So 2 plus 1 is 3, and 2 minus 3 is negative 1. So we're just going to multiply 3 times negative 1. That gives us negative 3. And we put that answer right in front of the a because that's our coefficient. Okay, so 5 equals negative 3a. I'm going to continue up over here. I'm losing some space there. So to solve for a, we have to divide by its coefficient. So if we had 5 equals negative 3a, to get the a value, we have to just divide by negative 3 on both sides. So the a value is going to be negative 5 over 3. We put the negative out front of the fraction. Basically, it's just this fraction right here, but I move the negative sign out in front to show that this parabola opens down. It's reflected in the x-axis. So now that I have the a value, I can create my equation. So all you had to do is you had to use the equation in general form to find the a value, and then your final answer is going to be the whole equation y equals a value, which you've just figured out, bracket, x. What are the roots now? Well, we have them in here. We have plus 1 and minus 3 in my bracket. So x plus 1, x minus 3, and we're done. This parabola is reflected in the x-axis. It's stretched vertically by a factor of 5 over 3. How come I said stretched instead of compressed? Because it's a fraction. Usually a fraction is compressed, isn't it? Well, if you look at this fraction, 5 over 3, is that less than 1 or greater than 1? Well, 5 over 3 is 1 2/3. It's 1.67. So this is bigger than 1, which means I'm stretching it. So stretched vertically by the factor of 5 over 3. And it also has roots of negative 1 and positive 3. Let's do an example where we have to use vertex form, where we can't use factored form because we don't know the roots. I'm going to move this out of the way here. In example 2, let's say we're asked to find the equation of a parabola with a vertex of 1, 4, and it passes through, the point 3, 3, negative 8. Okay, that's the information given. First step, do I have the roots? Well, no, I don't have any roots. When you don't have the roots, you use vertex form. So y equals a bracket x minus h squared plus k. That's the general form that we start with. Now what happens next? What's special about this general form? Well, what's special is that the vertex goes in there. So this vertex is going to be used for h and k in my equation. That's the first step. Now when I substitute the values in for the vertex, I have to remember in the brackets I changed the sign. So it was a positive 1 over here. It's going to become x minus 1 in the brackets. We don't forget the squared sign. Easy mistake. Don't do that. And we plug the 4 in as their k value. So I plugged the vertex in first. Next, I have to say, okay, what else is given in the question? Well, we're given another point. We're given the 3 and the negative 8. So let's take the 3 and the negative 8. Let's substitute them in for x and y. Remember, first you substitute in what's special to that form. So in factored form, you plug the roots in. In vertex form, you plug the vertex in. Then the other additional information gets used for the x and y in your equation. When you do this, regardless of what form you use, you should be left with a as the only variable that's left to solve in your equation. So we're going to plug our values in for x and y. Y is negative 8, and the x value is 3. So next we're going to follow BEDMAS. 3 minus 1 is 2. So we're doing 2 squared. And 2 squared is 4. So when we plug it into, or when we reevaluate this equation, we're going to put the 4 as our coefficient of a. We're going to sneak it in front of the a. That's just a result of saying 2 squared, or 2 times itself, is 4. Well, instead of putting a4, we're going to put 4a, because that's how we're supposed to show proper form. So next we're going to solve for a. We have this 4 over on the end that needs to be moved to the other side. Remember when you rearranged, we're going backwards for BEDMAS, so we're moving the addition and subtraction first, and then at the last step we're going to divide by the coefficient. So negative 8 used to be plus 4, now it's minus 4, equals 4a. So negative 12 is equal to 4a, which means we divide by 4 to get that a value, and a is equal to negative 3. That's our a value. Now all that's left to do is to plug that into the equation. So we know that, the a value is negative 3. So we're going to take that negative 3 and we're going to plug it back into the original equation. So the equation is y equals a bracket x minus 1 squared plus 4. Part of the advantage of taking a first initial step to substitute in only the vertex here, or only the roots, is when you go back to give your answer, you can look back up to that step and say, okay, I'm going to copy this exact step out, except I'm going to put my a value in where the a goes, instead of having to worry about plugging things in again and maybe making mistakes with the signs. So finally, this equation, y equals negative 3, x minus 1 squared plus 4, this is the equation of a parabola that is reflected in the x-axis. It's stretched vertically by a factor of 3. It is translated 1 unit to the right and 4 units up. Remember, when you describe a transformation, you talk about a vertical stretch or compression in terms of a factor of, so stretched vertically by a factor of 3. And when you talk about a translation, when you're moving it up or down, left or right, you're going to say it's translated by 1 unit to the left, use the word units, and 4 units up. So if I asked you to write the equation of a parabola with a vertex you would either be giving it to me in, what the heck did I just do? Hold on a second.